Good afternoon, I'm Ana Victoria and I'm part of the team Engineering Industrial Design. Our team is conformed by Axel Zúñiga, Alberto Ramirez, and I.
We designed the turbine and centrifugal pump that is basically a centrifugal and turbine and a base. The turbine and the centrifugal are locked to the base with some screws and nuts. Those plans were made by Elmer Verburg. The turbine and centrifugal pump is conformed by 22 components and some screws and nuts that we download from the MacMaster catalog. Those screws and nuts were used to lock all the components to the base and the foots from the centrifugal and the turbine. Here we can see a section view from the turbine, a top view from the machine, and a right view from the machine too. Those views were really useful at the moment that we were assembling all the components in order to get to the final project. Here we have two section view from the centrifugal pump that was really useful too, and we have all the components and his metric size.
Now I'm going to present the machine that we made. Here in this carpet we put all the assemblies and all the pieces that were needed to make the final assembly, and the final result was this one. A functional machine, very aesthetic, and that have a lot of motion links and a lot of pieces also. Here we can see the joints that we made were about like more than 50 because we use a lot of screws and nuts, some motion links to make all of these dependent. If I move something from here, all is going to move. The way it works in a simple form is basically some gas enters to the turbine. This turbine starts to move, and the shaft that is connected to the turbine made the little pulley to move, and this system is connected by a band that goes to the big pulley, and this one moves another system that we have inside this housing, and basically is the way that it works. Now you are going to see a video where you can see how it functions.
Here we have the exploded view, which explains the position of each component. In this table you can see the quantity, the name of the component, the number of the component, and some comments, and the type of material. Here we have the render to show us a more realistic way the machine. And in this side we have the orthogonal view that shows the top view and the bottom, and the centrifugal pump section view and the turbine section view. And on this page we have the poster of each component with their each name, and at the end we have the screws and nuts that we use and the quantity. I was in charge of the technical drawings and to put it all together in the posters with the screws and nuts. And one of my difficulties was to find out what was the depth thread of each hole.
I was in charge of the assembly, the video, and the exploded views. The difficulties that I had were that the assembly had a lot of pieces, and that made a little difficult the task, and also in the exploded view it was very complex to make all the pieces visible, but in an aesthetic way.
I was in charge of doing all the views in render, and also I had to create some of the parts of the machine. One one of my principal difficulties in this project was that I had to create all the views in the render. So I spent a lot of time doing this task, and at the final we didn't use those views, so it was a waste of time.
Regardless, we have specific tasks. We collaborate and help in all the process of making this machine. And also our conclusion is that it's very useful to make a project like this, because you can learn and you can make like a real use of all the knowledge that we saw in class, and we can make like a fusion, literally, of all the things that the teacher taught us. That's all.